back after a little while between videos. It's been feeling kind of under the weather for the past few days, plus I was running around like crazy at work, so really haven't gotten anything done down the shop. So, but had a new present come in a couple days ago. I just cleaned it all up to get it ready to test, and what I have here is a Palmgren milling attachment. These weren't, these were basically universal. They'd fit on any lathe, and you have basically a regular Palmgren vise like you've seen before with the hardened jaws. Bottom one has the V slots in it. Here, that's your regular vise, but then on the back of it there's a dovetail, well, tiny dovetail with some slots, and then this mounting bracket here, and you can see the protractor, if you can see the numbers on there, and there's a protractor right here. This right here is a gib block. The actual adjustment for the gibs, or the gibs themselves, are these 3 screws and these 2 plates. The tighter these screws, the tighter the gib will push down on the V-way, or on the dovetail rather. And then when you get the setting you want, this is just a screw. There's a brass plug on the inside of this. You can tighten it down and kind of keep it from flopping around a little bit. This is a Palmgren 250. I believe they went up to a 450. I'm not sure what the difference in the sizes are. The 150 is much smaller than this, and you can see here is your adjustment to move the whole thing. You can look that gib here. Move the whole thing up and down, and it is graduated. I don't know if that'll show up real well. Now that's part of the screw itself. It's not a collar that you can adjust, so it's not that useful, but it is there. And then this bolt right here will allow you to swing the whole thing side to side. Now, these were meant to sit right on top of your compound. You would actually use your lantern to kind of sandwich it in place and hold it. I'm going to try it like that for now. More than likely I'm going to figure out something a little bit better to eliminate the compound itself and bolt it directly to the cross slide with a bracket. What'll probably end up happening is it'll be an angle bracket with the little dovetail slug on the bottom. Put that in the hole, and then I'll drill and tap a hole straight into the cross slide. There are actually 2 on the cross slide that are meant for the actual self-bend milling attachment. And I'm just basically wondering, or really want to see how this works out. I have a feeling it's going to be pretty floppy and flimsy, just because you not only do you have this hanging out all the way over on the end, but you also have a set of gibs to deal with on the compound, and a set of gibs to deal with on the cross slide, and then a gib to deal with on the saddle. The way the lathe is made, the work spins towards you, and you have a stationary tool bit, so all the force on that tool bit is going to want to force a compound or the entire carriage assembly down and into the bed. This, unfortunately, you're going to have a spinning end mill. Get a big one here. You're going to have a spinning end mill like this, so not only is it going to force it down, but also on the back it's going to want to flip it back up. And depending on which way you're feeding the compound in and out, in a climb cut or a conventional cut, if you climb cut, it's gonna want to move your entire cross slide in and out. It's going to want to grab it and pull it because of the just the backlash in the screw as you turn it. So that's something you have to deal with, and more than likely I'm probably only going to be able to take, if I do a climb cut, it'll be a finishing cut, very, very, very light, like only maybe 1/1000th or 2, so that way it doesn't grab and push the cross slide. Everything else is going to have to be conventional milling, otherwise it's just going to keep going back and forth. Also, the self-bent compounds are really, I mean, if you look at them, they're not square angles. Nothing on the lathe is square. Everything's all round. This is meant to sit on a shoulder, like so, flat up against it. I'm not going to be able to do that, so that's also another place for this to flex back and forth, like that. Everything is gonna be held into in a collet. The collet setup. You don't want to hold an end mill in a chuck. It's not good. It's not a good practice. And can you get away with it? Probably. I wouldn't recommend it. If you really do have to do it, I'd wrap a piece of paper around the end mill. Especially like a brown paper bag or something like that. It'll keep you having from a hardened surface against a hardened surface. It'll give you a little bit more grip. Again, not something that's fairly recommended. In addition to this, I also got an assortment of end mills I picked up in auction. So it's a big 3/4 inch one, which will have no use on my lathe, but this is a 3/4 inch with a 1/2 inch shaft. The 3C collets only go up to 1/2 inch, so this is still a little bit too big. Just to show you one thing too, here's a regular 4 flute. Here's a 2 flute. But I want to show you a difference between, I think I have one in here. Thought I had one in here. Yeah, this one is. And this one is. Alright. Same size, 3/4, 3/4. This is just a double end mill. Now look at the edges, or the ends. See, this one has a center hole in it. This one doesn't. This cutting edge here goes straight to the center. This is a center cutting end mill. Non-center cutting end mill. You have the little center hole in the middle. So this one you could plunge cut with. You could actually go in and you could actually drill if you wanted to with this. You can plunge in and slot with it. These ones, you really, if you were making any kind of slot, usually you drill first and then go, because of that. So I have an assortment of all different kinds of end mills here, and apparently a bunch of tiny drill bits that came with it. I found this kind of funny that was in there. It's actually it's one of those little precision screwdriver sets, but I don't know if it'll show up on camera or not. Let me see if I can get it. South Bend Lathe Incorporated, South Bend, Indiana. Precision machine tools. I just found it funny. The other thing too is what I'll probably end up doing is using a 4-flute. I'm going to be testing in aluminum and steel. The reason why I want to try to use the 4-flute is because even though in aluminum kind of you want to use the 2-flute just because it's gummy, I have a feeling that when this, if you were to take the piece and go to face the end of it, the 2 flutes, when you're only going to have 1 flute in contact with the work at any one time. So around here and here, you're going to get a huge click, and I'll probably get a lot of vibration in it because that's hanging out on the end. Whereas on the 4-flute here, at any one time, I'm going to have at least two cutting edges in contact at a time. So I think it'll have a lot less chatter. I'll try it out. I'll put one of each in there and just see which one works better. So me set up on the collets, and actually one little thing with the collets too. They make end mill holders, and they make end mill holders for a reason. End mill holders are basically so they have Morse taper shanks or R8 shanks, whatever you want, or some of them are straight too, to actually hold in a collet. They go onto the little flats here with the set screw to keep your bit from spinning, and they'll also go into the shank. Now the shank itself here where it grabs, like I said, we'll have a set screw to hold this to keep it from spinning. The problem you'll have with a collet, the straight end mill in a collet, is you have a hardened surface against a hardened surface. It's kind of slippery. If you get any oil in there for any reason, or if you were on a conventional mill, you take a really deep cut, a lot of times these will want to grab and pull out. So that's just one thing you have to be careful of. That's why a lot of times if you look at old milling machines, you'll see a track, you'll see a groove. There's somebody cutting it, and it'll start shallow at one end and get deeper. That's from one of these slipping out of a collet. So what I usually do is, this is just some degreaser. Just before I use the collet. A quick little spray in a wipe. On the surface, the bearing surface of the collet there. Just make sure there's no oil or anything that's going to let this slip. So you set up on the lathe there and get these in a collet, and see how this thing works out. Alright, I got the end mill in a collet. Now, let's try to get this in place here. So you can see, because of the roundness of the compound on this side, it's not really that flat. I still have a little bit of rocking on there. So alrighty. So you can kind of see how that goes there. I gotta actually a bit in there just to hold everything down. That's not bad. Now I have the dovetail screws in this compound locked down as tight as I can. I also have these gibs here on the compound locked. The reason why I have it parallel, parallel with the cross slide here, is because this side of the compound is the only side that's flat. The front is rounded, so I don't want to put it this way on it and have that on the side. So, which is why I'm gonna end up, like I said, making up a better mount for this. Now, I mean, this is no real replacement for any kind of milling machine. This is just for light milling, really. You know, straightening something out, making a flat on something, making a small keyway. Actually, even the South Bend branded milling attachment technically was never called a milling attachment. If you read the catalogs, it says keyway attachment, keyway cutting attachment. That's all that was really meant for. But, you know, we'll see how this works. So let's try some aluminum first. Just get a picture of what the saw cut looks like right now. Let me see if I can get that better focused. That's what the saw cut looks like right now. Now, I'm not dialing anything in. I'm just going to throw it in there and have at it. So, we'll put it in this way for now, so that way we can do the face, and then we can make a slot in the top. So tighten this down nice and tight. And I have a 4 flute in there right now. And I'm going to go halfway through the stock so we can see the difference. Now the bit is spinning towards me, so when I bring it to the opposite side and pull it towards me, it's going to want to push this away from me, which will tighten up on my compound. If I go the other way here, every time I feed in, it's going to want to pull it, suck it into it, which is going to take the backlash out of it every time. So every time I move the compound, it's going to want to pull, compound pull. So I don't want to do that if I go the other way. So we'll go this way. That's about halfway there. We're only going to take a little bit off here. I'm going to lock down my carriage. Towel here. That's a saw cut, and that's what I just did right there. It's not bad, not bad at all. Alright, now I'm gonna take a little bit off the top here, but I'm gonna change over to a 2 flute end mill. So I think this 4 flute's just gonna end up getting clogged with the aluminum. So let me take that out. Yeah, it's a little rough. Let me give you a close-up of that. You can see that. You might be able to see that. You can see it's a little on the rough side there. So what I'm going to do is I'm going to go up maybe a couple of thousandths to, because that's what these ridges are, and do a climb cut and see if it can take it without shifting the compound all around, all over the place. This went up about 3 thousandths or so. Not bad at all. You can see a few of the lines in there. That's not too bad. Could be worse. Let's give it something a little hotter. Let me cut myself a little piece of 1018 steel and see how it goes through that. Alright, I just had to move the camera far away to be able to get a good picture of that, so you might not be able to hear any of the cut, but slow the lathe down a little bit. It's actually not too bad. Now I'm going to try just taking a little bit off the top here with the side of the cutter. That's actually a really good finish on that one. I'll bring these over to the bench and maybe we can get a better idea. All in all, not too bad. There, just get the attachment here just to show you some stuff. Alright, the biggest thing I just learned is after you're done adjusting your height on this, lock this down. If you don't lock this down, it's going to want to jump up and down and vibrate a lot. If you lock this down, that eliminates a ton of it. The other thing is depth of cut and speed. You can see this right here was one pass. It was a little too deep for the cutter. You can see all the chatter in there and the surface finish. This right here is one pass. That right there. And you can see the surface finish on that is perfectly nice and smooth. Same thing on this side here. This was multiple passes to get down to this depth. And we get that as a finish. The ends here, that was one pass on the end with the tip of the end mill. And that's actually pretty smooth. This right here is this rough surface. Here's the saw cut. This right here is the part that I went over with the end mill. And this is just that quick flat that I did. Now I just went down, over, up, over, down, over, and up, over. If I went 2 passes straight down, I would have probably gotten a better surface finish. I just wanted to see if, you know, doing the zigzag pattern would work on something bigger. You can go, you know, down, over, and up. But honestly, you'll be better off anything that's really big, probably with a fly cutter or something like that, which I gotta pick up one anyway. I did do a little slot in here off camera. It actually worked out pretty good. A little bit of chatter on it on this side here. It's a little rough on this side. But as far as depth and the finish in there, it worked out pretty good actually. Very surprised by that. And the steel actually surprised me the most. This is that last cut that you just saw me do. And that depth there, I don't know if you could tell, right there. Right here. That was one pass. And that right there is perfectly smooth. I mean perfectly. There's not even just a wrinkle in it. That worked out real well. Even on the inside here, these passes I did off camera a little deeper. You can see a few ridges here and there, but when you're on your finger over it, it's pretty smooth. And that came out that deep. This is the one that you saw me do with the end of the end mill there. That came out pretty smooth. And there's another quick one I did too. It's pretty smooth. All in all, I mean, if you control your depth and your feed rate, it actually works out pretty damn good for what it is. This unit here, I bought, and the only reason why I got it is because I got it pretty cheap for what they usually go for. Usually, you'll see one of these go for usually in the high hundreds, low 200s. I've seen them as much as $250. This I actually got for, I believe, 80 bucks or 84, somewhere around there. And basically shipped to my door. It cost me 100 and change. That's the only reason why I got it. Is I know if I ever got a regular mill and wanted to get rid of this, I could easily make that back. I mean, I just if I make up a nice plate for this to get rid of it sitting on the compound like that, I think it'll be a little bit more rigid. The hardest thing also, I can kind of put this in place and indicate it, and then use the holes that are already drilled in the the cross slide for the south bend milling attachment. There are 2 holes. Depending on the year, you may or may not have them, but they're 2 drilled and tapped holes. If I make up an angle bracket for this, basically remove this little fork thing, bolt it right up to that angle bracket, and then indicate the vise to parallel with the spindle, and then get a couple of those transfer punches and go through the cross slide and mark those holes. I should technically be able to put a bolt in there, and every time I take it on and off, it should be within a couple of thousandths, 5-10 thousandths or so of perfect alignment, and then just tap it into place rather than trying to get this on there and move everything around to indicate it. That's probably gonna be, that I can already tell is gonna be the biggest problem with this, is getting this into parallel with the spindle or offset to whatever angle I need. I have a feeling that's gonna be the major issue with this. It's not anything you're gonna be making some serious parts with. You're gonna be doing small stuff, and you make yourself some T-bolts for your compound, and you need a flat on something or a keyway. Definitely a go-to thing. But as far as using it in place of a mill, there's just no way. Which I never really intended it to be to begin with. Just wanted it to do stuff like this and this here, and square up a piece of square stock if I ever needed to. So I'm under no illusion that this is going to replace any kind of mill. But that said, I'm happy with the performance from it so far. We'll get some more use out of it. Now, as far as upcoming projects and stuff, I'll be getting to those soon. So the past couple of weeks have been pretty hectic, and this week is no different. I did pick these up, which I'm going to be incorporating into a project, either rotary broach or one of the tailstock centers or something. This is actually a ground Morse 2 taper blank. Supposedly this end here is unhardened. Supposedly this is soft. I got a Morse 3 reducer, so I could put this into the headstock, and I put it on there, and I did give it a nick with my file, and the file did make a mark in it. So it is soft. Was not hardened, at least not as hard as these the sleeve or the tang. How hard it is, I don't know, because even if any of you have ever bought when the quick change tool post, you have to machine the T-nut. Those aren't supposed to be hardened either, but they're pretty nasty metal to go through. So we'll see how these work out, and put those into another project. And I'm also working on a little it's going to be a series, probably 2 or 3 videos of tips on buying a lathe. And the first video will probably go through how to just identify a lathe, the differences between the brands and stuff, and common brands that you're going to see like Atlas, Craftsman, Logan's, stuff like that. And then we'll be using mine as an example of how to check wear and stuff like that. So that's going to be an upcoming series too. So I'll get around to all that stuff, as soon as I can. Anytime I have nothing to do and I'm sitting around, I do come down here and play or start up a video. I got a couple of different things going on. So we will get to those eventually. Just bear with me, especially in the next couple of weeks. Other than that, hope you enjoyed this video, and I'll see you on the next one.